Hey there, my name is Alejandro, and welcome back for day 288 of me doing daily code challenge after I reach 1 year's worth of green contributions here on GitHub. So today's promise for April 30th, 2025. Without further ado, let's get straight into it. Okay, typical LeetCode easy. Wait, that's super surprising. Because, wait, janvier, février, mars, avril. Yeah, April 30th is the last day of the month. Is this the April Fool's joke? Because this is not a counting problem for the first time in forever. And the last problem of the month is an easy. Is this LeetCode just doing an April Fool's joke? Okay, that's pretty funny if so. Just a million count problems and a LeetCode easy down of the month. I was really expecting a hard. I was telling my friend Osmani, let's wait for me to do the LeetCode before we go bouldering and clean out my room, because I want to just get the LeetCode out of the way and not do it at night, because I thought we were going to get LeetCode hard. But you know what? There we go. We get a LeetCode easy. All right, so find numbers with even number of digits. Given an array of nums of integers, return how many of them contain an even number of digits. Okay, I'll put 2. 12 contains 2 digits, even number of digits, odd number of digits. Yeah, okay, so this is easy. So one way we can do it is, we could do this in one line. So map return sum of length of string of num modulo 2 even number of digits. For num in nums. All right, something like this. Submit. And there you go. Okay, doesn't seem to do the thing. Let me refresh the page. Okay, it's not going to show us the completion streak, 288 days and so on. Okay, not aware. Which is sad, because usually the end of the month is when you get the big token and so on. Okay, well, no worries. We don't get it today. That's kind of unfortunate. But that should be the end of the month, I guess. Okay. I mean, another way we can do this is just we can do map. So we could do length of nums, string num, string num, yeah, okay, we did it in one line. We know how to do it in one line. Let me just not get fancy here. Okay, so that's how we do it in one line. A better way is, instead of using strings, let's do res equals 0 for num and nums. Let's compute the number of digits, right? Equal to true. Num digits is equal to 0. While num is greater than or equal to is greater than 0, num divide equal by 10. Num digits plus or equal to 1 plus if num digits modulo 2 equals 0, res plus or equal to 1, return res, right? So something like this might be a little bit faster. Submit. Okay, no, not quite. 42 ms. What was the speed of this one in comparison? It's a little faster. Maybe we could do math.log, but no. Yeah, if I did math.log, let me try something. Because we don't actually care about the digits themselves, right? So here, let me do Python 3, import math.log, let's do 103. Base 10, please. Now, do 1003, yeah. So it'll be truncate, right? Because something like this is, yeah. but yeah, so if I do int, that truncates, right? Yeah. Here we'll say num digits is equal to math.log of num base 10. Int is plus 1. Num digits modulo 2 is equal to 0. That's plus or equal to 1. Something like this. Okay, that's accepted. So yeah, we don't actually need the digits themselves. We can just do a log. What is wrong here? Oh, so if I do something like 1,000, num modulo 10 doesn't equal 0. Might need to be an equal here. Okay, there we go. No, okay, 1,000 is 2. Oh, it's just not getting it right. Oh boy. It's just not getting it right. That's annoying. That's pretty annoying. So it's just like, yeah, it's a correct formula, but it's just like, that's pretty annoying. Yeah, because this should work, but Python's not doing things right. Return 1. Yeah, because that's a shame. Yeah, and that's 3ms. Math.log of 1,010 is returning 3, but Python returns 0.99996. Yeah. Yeah, that's kind of unfortunate, right? And here we can just do a little bit of this. Right. Yeah, and 0ms beats 100%, which is absolutely what we love to see. Okay, but at least we got a 0ms beats 100%. But yeah, you know what? We'll just keep it as the... you know what? We'll just come with the... yeah, we'll just get rid of all this. We'll just keep it a beautiful one-line solution. Here we can just do map length of string of num modulo 2. Nums. And length of nums minus sum of map. Lambda num maps to that. ut. Yeah, that's nice. Or we can do and 1. Just like in basketball, and 1. Right. Yeah, no matter what, it's the same shebang, the same spiel. Is equal to 0. This would be the most understandable way. And there we go. Bada bing, bada boom, we have a working solution. Okay, so nevertheless, as always, in all my videos, I do a quick recap of as I will solve the problem. So this one, I was just having a little bit of fun, but the idea is that given an array nums of integers, return how many of them count an even number of digits. So there's really two ways that I usually try to figure out how many digits a number has, or getting all the digits themselves. One funny way is if you care about just the number of digits, you could just use math.log. Now the only problem is that some numbers like 1,000 log base 10 should be 3, but like Python does some roundoff errors, so maybe don't use math.log. But usually you have two ways of going about it. Option one is to either just convert the number into a string and just loop, like, you know, through all the numbers in the string, right? Very straightforward. Otherwise, another one is to just keep dividing by 10 and truncating, right? So here's like, you know, if I have a number like, let's grab this number right here, right? If you want to know all the digits, right, this is what I mean. So if my num is equal to this, then I have two options. One is to convert the number into a string, right? And then I can do, like, you know, for digit in str num, right? Print digit, right? And I'll have all my digits, right? So I can essentially convert the number into a string, iterate over the number, all the digits, and count how many there were, and that way I can know if there was an even or an odd amount of digits. Another way is to essentially do measure by 10. So here I can do something like while num is greater than 0, let me do print the last digit, which will be num modulo 10, and divide num by 10, but with truncation, right? So double slash, so that you, if there's any remainder, you get rid of it, right? And so here we'll have the same thing. It'll just be in backwards order, right? 6, 9, 8, 7. By the way, we can use this to count the number of digits there are in total, right? So here what I did is, like, for every single number, I'm just going to use the string way just because I'm being lazy. And essentially what this does is, like, okay, so some map, okay, this might not be as readable, obviously. What's going on is essentially I'm taking all of nums, and for each number, I'm going to run it through this function, lambda num maps to this thing. What I'm going to do is I'm going to take the string version of that num, right? So for example, something like 7896, I'm going to grab the string version of that num, right? So if num is equal to 7896, then string of num is equal to this, right? And then I'm going to take the length of this guy. So I'll take the length of string of num, right? In this case, it's 4. There's 4 digits, right? Now we want to know, is this an even number of digits, right? This is even if the thing modulo 2, the remainder is equal to 0, right? So in this case, it'll be true. So for each number in nums, I'm going to map them. So I use the map function, where my function will take a number and say, hey, is the length of the string of num modulo 2 equal to 0? I.e., it'll convert the num, and it'll return a Boolean, true if it is even, false if it is not, right? And so for each number in nums, I'm going to map it to a Boolean. It'll be true if it is indeed even in digits, false if it is not, right? And now once I have mapped nums in this way, right? For example, if I do this, and I take some number of nums like this, right? If I do map nums with a lambda function, which is num modulo length of the string of num, modulo 2 is equal to 0, right? In this case, I don't have num, so I'll have to do this. Right, but if I map this, you'll get a map object. So if you really want, you can convert this into a list just to see what's really inside of the map. Right, but here we'll have true. Okay, this has 2 digits. That's even. And then we have a false, 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 true, right? Odd, 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 even, right? Which is good in terms of the number of digits. It does exactly what we want. Now what we want to do is, okay, all the trues represent all the numbers that have even amount of digits, right? So here we want to count. Okay, so I guess this is a counting problem. How many of them actually have even digits? So we want to count the number of trues that we have. Well, in Python, a true gets converted into a 1, and a false gets converted to a 0, right? I can essentially prove this to you. If I do 5 plus true, this will give me 6, which is the same as 5 plus 1. If I do 5 plus false, this gives me 5, right? If I do int of true, right, it'll give me a 1. If I do int of false, it'll give me a 0, right? So here, I can take the sum of all of these guys, which will be plus 1 for every true, plus 0 for every false. So it'll essentially return to me the number of trues in that array, right? If I take the sum of all the trues, which is exactly what I want, because the number of trues is indeed how many numbers I have that contain an even number of digits. So all I do is I go through every single number in nums, convert it into a string, get its length, modulo it by 2 and check if it's 0 to see if it has an even number of digits, and then I do that for every single number and count how many of them ended up being true, right? And there you go, we have a reasonably efficient solution to this problem. I found a way to get to 100 mess, but it was using math.log, and I had, like, you know, a forced case because math.log of 1000 base 10 is not returning exactly 3, so I didn't want to deal with it. But it's not all too big a deal. Plus, it's always nice whenever you can crisp out a beautiful one-line solution like this. So you might as well do that from time to time. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.